Hey everyone, we're back again with the amazing Johnny. As we spoke last week, we wanted to continue our conversation about autonomous agentic workflows. And one of these key components really that makes that happen, what a little bit makes it special with the Vertesia platform is how we introduced what we call parallel work streams. And today, Johnny and I want to dig a little bit deeper into this, show you some examples of what that means and how Vertesia's parallel workstream features differs from traditional workflow orchestration, right? So it's a game-changing feature for sure. It is the difference that you might be thinking like other tools that allow you to build agentic workflows or to build orchestrated workflows, but more like maybe like a LangGraph or an NHN or a MIG. So we want to understand how Vertesia is doing this very differently, because we are an agentic platform. We are not prescribing the workflow per se. It's not like we're creating nodes and nodes in a workflow overview. We have a more autonomous approach to all of this. And yeah, Johnny, what can you tell us about how our orchestration works differently than other tools would do it?
Yeah. So a little background. I've done a lot of workflow building in the past. I don't know, 10 plus years ago, until a couple years ago. I was building workflows the traditional way. And so the traditional way of building workflows is you map out all the decision points that need to be made. And again, this could be writing code, it could be a drag and drop interface. Right. I have a good amount of experience with RPA technology as well, but all that's deterministic. And so you have a starting point, and then you have, right, some actions that will happen, and then you have some decision points, and all that's mapped out. And the person mapping that out is me or whoever's building the workflow. And the
Yeah.
problem is when a decision needs to be made that hasn't been thought of, or when an error is run into that hasn't been um, accounted for in the workflow, it will fail. And so workflows traditionally they've been great, but with the introduction of LLMs, they've allowed us to build autonomous agents. And so I think it's worth distinguishing kind of the main difference, which is a workflow is going to be deterministic. It's going to have certain steps that are pre-thought out by a human. An agentic workflow, or an AI agent or autonomous agent, whatever you want to call it, right? That's going to be a it's a software process is maybe the best way to think of it. And it's going to have kind of an LLM in the middle as the brain. And it's going to come up with a plan for itself. It's going to execute that plan. And as it executes that plan, it's going to periodically stop and check its work
Mhm.
and make sure that what it's doing is still aligned with the ultimate goal. And so it's more goal driven than step driven. And the agent is the one that's deciding all of that. And to make it a little, I think, more visual for people, I have a slide that I think does a pretty good job of an overview. And so this is this is really how an agent works. Now, we'll talk about parallel work streams in a minute. For right now, this is just one agent. But essentially what happens is it takes some input from the user, and that goes into the agent's working memory. And then it's essentially a loop. And so each loop, it's going to understand what it needs to do. It's going to select the tool, right? So the first thing it might do is create a plan. And then it's going to basically execute that tool, which would be planning. The output of that is going to be the plan, and that's going to get fed back into the working memory. And then the agent says, aha, I've got a plan to work from, right? Let's start with step one. Step one is, research something. So then it's going to say, what tool do I need to research something? Well, I need to search the web. Let me grab that tool. And it's going to continue to loop through that until it's essentially achieved the goal that it set out to achieve. And so the main kind of benefits here are it's much more resilient. It's adaptable, so it can handle, right, unforeseen errors. Right, if there's like a timeout with a certain system, it won't just fail. It will recognize it's a timeout and then wait, and then check again, and then wait, and then check again until it works. So it's very resilient. There's a lot more complex use cases you can handle with this type of workflow. And it's also a lot faster to build than traditional workflows because it's all done in plain language, right? So Vertesia gives you essentially all of the components you need, the tools, all of that. And all you need to do is basically instruct it on what you want it to do. and then you kind of design
Right.
the system and the instructions you give it, but it's all done in plain language, so it's super, super fast.
Right. So the agent has the autonomy to make its own decisions, right? And we talked about in our last vlog last week where we rather give it a goal and the agent figures out how to get there using all of these tools. And this is a perfect chart to show here because it demonstrates how an agent is really more like a circular flow of a loop coming back to the beginning and saying like, okay, what have I done? Make an assessment on its own actions, right? And then taking the plan forward or changing the plan if it sees that a certain method or a certain approach didn't work. It's going to refine its plan and revise and improve. So that's a very strong tool. But now, Johnny, maybe moving over into the fundamental differences between traditional workflow orchestration, like you would have like an N8N, you might have a Make, a Zapier,
Mhm.
right? Where most people know how to do this is building workflows in a like a visual graph, connecting dots on a map, like a flow chart almost, right? But in that, you would be predefining every node. You make every connection and you would decide on every node, okay, here we're going to use this model and here's the prompt for that model. But it's sort of a deterministic workflow with if and then at its lowest sort of um, decision points that you
Mhm.
hard code into that process. So that's manual orchestrations. So how does that differ from a parallel work stream, the way that we have implemented that with our autonomous agents? And the chart that you just showed is only one agent, right? But now we
Mhm.
think that this is becomes a master agent that basically invokes a number of sub agents that do these parallel work streams. So how does that work?
Yeah, so a good analogy is if you think about, right, an agent that can kind of reason and work autonomously, it's it's going to be similar to one human. When we have parallel work streams, that now becomes uh, not just a human and really not just multiple humans, but it becomes a team of people. And so it will have the orchestration agent, which is kind of the main agent that's gonna monitor everything, and it's going to you it's going to use tools and it's going to use its reasoning capabilities to actually create sub agents, right? So it's going to basically copy itself, but it's going to do it in a way that can be more defined for a certain task. So, for example, if it needs to do, a couple different things that it can do in parallel, like so, if it needs to, query a database, but it also needs to research the internet to find information, and then it also needs to read a bunch of contracts. Instead of
Mhm.
doing that one by one, um, it's going to do it in parallel. So it will say, I need to, research the web, query the database, read the invoices, and then I need to synthesize all that information.
Yeah.
And it's going to do it in parallel, just like you would a manager on a team might give three people a task and say, you do this, you do that, and you do that, and then bring back what you have to me.
And that the brain is doing that as it finds out how it gets into the more specifics of executing against the task it is given, right? So
Yeah.
we don't tell in the beginning where to start these work streams. It is inferring itself, oh, now we're getting to more complexities. You might say, like, hey, I need a financial analysis, a competitive landscape, a management assessment, a marketing position. So all of these are parallel work streams. It identifies as complexities and this is basically the orchestration, really, the brain, as you say, that the intelligent brain makes decisions when to spawn additional helpers for the task.
Yeah, and I think it's worth mentioning when we're talking about the brain and the reasoning capabilities, right? Where LLMs fit into that is the language, right? So if you think about how you as a human think, there's a lot more to the brain than just language, but in terms of right how these agents are working, it uses the language to think through things. So if someone says, "Hey Johnny, I need you to, go get me a cup of coffee." In my head, I'm gonna, be thinking, right? Okay, I need to get coffee. I know there's a Starbucks down the road. I'll need to get in my car before I do that. So I'm gonna get in my car. I'm gonna put the key in. So I'm thinking in language, right? And so that's how these agents are able to do that is because
Mhm.
everything ultimately is done. using language when you're kind of reasoning through tasks.
Yeah. But now I'm sending you to get my coffee, right? And Starbucks is closed, so you have to find another Starbucks. So it takes them more time. But all the while, I'm working for you to come back with my coffee, right? So there's certain dynamic, and normally I would have to wait for each of these tasks to get completed, right? So they're kind of blocking the progress of the overall orchestration. How does that work? How can that be optimized?
Yeah, so the AI landscape is obviously evolving very fast. At first, there were these large language models, which was kind of a single call, and it would, basically, we don't need to go into details how they work, but ultimately you could kind of send information and it would get information back. And then we went into agents, which was that loop I showed you, right? And then we went into kind of agent swarms, which is multiple agents. And now we've gotten to the point where we're still doing, you can think of them as agent swarms, but they're much more intelligent. And so you mentioned, the blocking and the right, the agent basically just waiting for things
Mhm.
to come back to them. So now with Vertesia, what we've implemented is the ability for these main orchestration agents to see what their child workflows are working on and what their sub agents are working on. And they can actually check in and say, right, so think of it as you tell me to go get a coffee. And I'm going, and then you call me halfway through and you say, hey, right, just checking in. Have you gotten the coffee? I say, oh no, the Starbucks was closed. I'm going down the street, right? So now you have that information being updated in real time. And it's doing that not just for one agent, but it's doing that for all of the parallel work streams, right? And it can do that. I mean, we've seen instances, I think, where we had 75 sub agents working at once. And
Yeah,
this main
crazy. The
and this
yeah,
main
the benchmark.
orchestration agent can handle all of that. And it basically is
Yeah,
checking in on them. Whereas before, right, kind of early agent swarms, they would kick off additional workflows, but then they were blind and it was completely isolated.
yeah,
And they had to
yeah,
wait for it to come back. And if it didn't come back, it might throw off the whole workflow because that agent doesn't know
yeah.
what's going on.
So it's really help me understand. So it's really the master agent. So it's first of all, I think, correct me if I'm wrong, it's creating a brief for every single other agent that it spawns. It's giving it instructions. It's giving it certain tools it can use in order to perform the task. For example, coming back to the where's the next Starbucks? It might get a navigator tool, right, in order to
Yeah.
find the next best Starbucks to stay with the analogy. But also it will tell it like methods how to compensate and when to report back, right? So all of that comes together into making each work stream completely isolated in its own execution environment, but still becoming part of like one system. It's like an organism always, or almost, right? Where the different components, different cells work together to form an organ.
Yeah, that's a really good analogy. And I think it's worth mentioning too with these agents, there's AI agents are amazing and they're very powerful, but they're still limited in what they can achieve. So, for example, if you have 10 resumes to go through or 10 documents to read and summarize or make a decision based on that information, a single agent could do that, right? But now if you take that and there's 1,000 documents, well, an agent, right, is only going to have the context window of its of the LLM, right? So the context window might be 200,000 tokens, it might be a million tokens, which are similar to words. And right, there's ways to handle that context window, like checkpoints and all that, but ultimately, there's only so much it can do, right, itself. And so being
Yeah,
able to specialize other agents in ways allows it to basically scale the amount of work it's doing, um, and do so a lot more effectively. And so again, this gives the now we're going from reading, one document to reading 10 documents to being able to read, right, a million documents, right,
yeah,
and doing so just as accurately as that single agent that was doing, right, 10
yeah.
documents.
So it is managing these sub agents, and as you said before, it was in initial months would just spawn another sub agent and let it run, but now we come into the management of these sub agent, right? Like a that's a revolutionary thing. It might sound small, but it's huge because it really helps with this autonomous orchestration.
Yeah, it's worth mentioning too, real quick. The sub agents that these agents are spawning can also have different models. And so
Mhm.
an agent might decide, oh, this is going to be I need this to be right quick. So it's going to give Gemini 2.5 flash to, sub agent A. And then maybe sub-agent B needs really, really complex reasoning, or maybe it needs to write code. So it's going to
Yeah.
say, okay, I know the best model for that. It's going to be, right, let's say Opus or something like that. And so
Yeah.
it's really specializing these agents, not just in the instructions it's giving it, but how it's basically configuring the agents as well.
Yeah. And also what we see from real world examples, I mean, we cannot, of course, show too much of the actual clients that we're working on, but what we're really seeing is like a factor of 4 to 5 of speeding up processes, speeding up workflows, taking like a process like I don't know, financial analysis, regulatory review, management assessment, and all of that might take 8 hours for a single agent sequentially to work through this. Even Johnny, even if we overcame the token limit, right, the sort of short-term memory that the agent would somehow have to juggle. You mentioned tools that a Vertesia has for cases like that, where it's about checkpoint and memories that get summarized and stuff like that. So but really, we're able to bring it down from something like 8 to 10 hours to something like a 1 to 2 hours, right? And with the same consistent output, and with the quality really in the end of a quality assessment that the master agent will do against the output of every single sub agent. That's another important point. Quality control. So at the end of the orchestration, when every work stream reports back to the main orchestration agent, there's a quality control, right? Did it hit the marks? Did it deliver what the original brief that went into the spawning of the sub agent? Did it hit the marks? Did it check all the quality controls that are put in place? So which is a really important feature when you see that it's not just blindly firing off, right? It is a self-regulating system that where the outputs are emerging as it is progressing and creating and moving forward uh, through finding the best possible path to a solution. Did I say that
Yeah, and
right?
the quality is a really good point you brought up because scale is one thing, right? Being able to do stuff faster, which it absolutely can do, being able to do more, which it absolutely can do, but
Mhm.
also the quality, right? So agents have the ability to check other agents' work, and so I've had agents create other agents, and then I can actually see them checking the work, right? And if the work is not adding up or it doesn't make sense, then it will actually, either spawn another agent to redo the task
Mhm.
or it will reprompt the existing agent. And that's something that's really, really powerful because again, there's everyone's aware of the hallucination problem, right? And so the solution we found to that is basically having agents being able to double check other agents is one of the main kind of
Yeah.
solutions we've found there. And that is going to drastically increase the quality. And I have nothing I can show, but right, there are examples I run into every week where an agent will identify a hallucination of another agent and then fix that. And again, this is all happening before
Yeah.
it gets to the final person.
That's really life cycle governance, right?
Yeah.
That is like it's really checking in on itself, checking deadlines, checking outputs, which tools have been used, did the agent go rogue, hallucinations? So this is like we're baking that right into the agentic platform itself, so it becomes a normal behavior. As you just going in as a person who's just working with the assistant, giving it a problem, all of these things are happening in the background, of course. But here's the kicker, Johnny, right? We're not a black box. Any of what we're talking about right here, you are able to follow um, the very in a very, very detailed sort of log view that allows you to dig into every single of these uh, agentic stream spawns that we came up with, right? Work streams. You were able to dig into every single tool that they used, every single prompt that was submitted. You can go as deep as you want or stay as high as you need. But this is really the power that the Vertesia platform gives you these capabilities to work at a very high level. It will help you in solving problems, but if you need to troubleshoot, you can go all the way down to the token level if you want to understand. And then the platform also it can sort of I'm losing the thread. The platform can also sort of improve upon itself, right? So when it sees an error, how does the error handling work with all of this?
Yeah, so the error handling works. So there's a lot to unpack there, but yeah, so the error handling is really interesting. And so when agents run a process, right? And again, we'll just talk about one agent, but this expands to right when you have when you have 100 agents working for one agent, right? All the same stuff applies. But if we zoom in on just one agent, when it runs into an error, it will actually read the error. And so when it reads the error, it will basically take that and interpret that error and try to understand what it needs to do differently. And so a good example might be if it's trying to read a very, very large document, right? Maybe there's a timeout issue, or maybe there's, for whatever reason, the large document is hard to analyze for the agent, right? If it gets an error that says, document, too large to analyze, or, timeout issue, then that error will get fed back to the agent, and the agent can actually say, oh, okay, I see this is a very large document I'm working with. Let me actually, right, do this in sections, right? So let me take the first half of the document and analyze that. Let me now take the second half of it. And so it basically will understand almost its environment as it's running. Like, okay, I'm working with a large document, right? I have these limitations with large documents. And guess what? There's tools on how it can handle, right, large documents, like reading part of a document rather than opening the whole thing.
Yeah. And I mean, all of this really, it's a shift of a paradigm, right? It's not too big of a word to say here, because it's we're taking a number of things and moving something that was absolutely static into a dynamic, self-regulating organism almost, right? It is taking things from a sequential processing into a true parallel processing, including checks and balances, making sure it is quality controlling within itself. It
Mhm.
is the whole monitoring and governance, right? That is built into the tool that allows
Yeah.
you to understand and really see what's happening. And it's also from a sort of fragmentation that you as a user, when you plan out a workflow, right? And we talked about this also on the last blog that we did, where you would go from the input in order to achieve a certain output, but now you're working your way backwards, right? It's from a fragmentation more into a synthesis, right? Where the automatic consolidation of these parallel work streams get unified into results, right? Versus you having to figure out every single step and testing and coming back and testing again. The agent's taken over the work. So technically, the agent becomes the orchestrator,
Yep.
helping you in doing that way more efficient than you could ever possibly do yourself.
Yeah, and I actually have a really good example if you want me to share.
Oh, please,
On
yeah.
on basically again what you just said is exactly right. Right, you're focused on the end goal, and then you let the agent figure out the steps to get there.
Mhm.
And I catch myself sometimes still trying to tell the agent what to do step by step. And again, there's certain use
Mhm.
cases where that is the right approach, but especially when you're just testing out a use case and exploring a use case, it's really good to just give the agent what you want, right? Here's the goal, here's what I expect, and then let the agent find its way there. Because sometimes you think you know the right steps, right? But the agent is going to know the right steps better than you are because it understands all the tools it has, its internal system. And so this is a really, really cool example of one where I'll show you the prompt, right? So I was talking to a client, and I wanted to show them they had questions around parallel work streams. And so this is what I put together. So instead of me coming up with, I need you to demo parallel work streams, right? I'm gonna tell you demo this, do this, and me coming up with everything, right? And then having the agent run. I basically told it what I needed. I said, right, I need you to demo your parallel workstream capabilities. I'd like to understand what different use cases you can help with, where parallel workstreams is preferable to a single workstream or a single agent. And so I even told the agent, I said, to make this a bit of a challenge for you, I'd like to orchestrate parallel work streams to explore parallel work streams, right? So it was kind of a meta task or almost like the movie Inception, right? I was basically saying, right, use parallel work streams to tell me about the value of parallel work streams. And so that was what I gave it. You'll notice I didn't give it any explicit instructions. There's no do this, then do that, then do this, right? I just told it what I wanted, And so the agent, what it was able to do, and this is just truly incredible in my opinion, right? So if you see here at the top, there's I can see all messages, right? So this is going to be everything, main agent and sub agent. And then I have this main tab right here. And this is going to be the main agent that's doing the orchestration. And then you can see each of its individual subagents, right? So it has one subagent for that, one subagent for a competitive intelligence work case, right? Multi-perspective. So there's a lot going on here, right? And this agent, right, this main agent can see everything that's happening with these subagents. And so you'll be able to see a little bit around what it's doing. So let's just kind of walk through, right? So first thing it did, it said, this is a fascinating meta challenge, right? The user wants me to, and then it broke out what I wanted into a task. Okay. And you can see the agent was even a little enthusiastic about this. It accepted the challenge optimistically. So then it's going to create a plan, right? It's going to learn the workstream orchestration. So we have skills they're similar to tools, right? But they're skills that basically give the agent additional information at runtime, right? So it
How to
understands.
use a tool. Hmm?
Exactly. I need to learn about, I need to do work streams. Let me dynamically inject that into the prompt that I'm using, right? And
Right.
give me
You give
that
it a hammer, and then you tell it like and the skills tell it how to use the hammer to
exactly.
build a house. Hmm?
Exactly. And here you'll see, right, after it learned that, it actually launched 5 different work streams. So it launched work stream 1, 2, 3, 4, 5. And then it's checking the status. So this is where, right? So this part before where it could launch work streams, this was right. We've been able to do this for a while in AI time, right? A while, where we could launch parallel work streams, right? But now this new capability we have is where it's able to actually check on the status of those work streams, see what that work stream is doing, and it's going to monitor them, right? So you can see here it has a thought. You can think of it as it said, excellent. All 5 work streams are running in parallel. They've just started, right? Uh, it says it's given 10 minutes, right? So it's putting a timer
Yeah,
on each work
each
stream
of them. Hmm.
to complete their work, right? And so the system's going to notify me, the agent, when the results arrive. And so you can see here right now it's waiting for progress, it's checking in on progress, it's checking the final status, right? And so all of this is really, really useful because not only is it right cool to see and really impressive, but when these agents run into issues, this main agent is aware. And so if this had been, 100 parallel work streams and it couldn't see what was going on with them, and maybe 99 of the parallel work streams succeed, but one of them doesn't, then that could throw off the whole agentic workflow. Whereas with this, it's going to be able to notice, oh, this one had an error. Let me restart it, or let me prompt it differently, or right. It can decide what needs to happen when the error shows up. And so again, it could completely launch another work stream. It could right just steer the existing work stream by giving it an additional information. So there's a lot of flexibility here. But you can see right what this agent's doing, which is in my mind uh, absolutely unbelievable when you think about all the orchestration that's happening, right? So if we just look at one of these subagents, and we can look at the details here, right? So this is one subagent, and you can see it's doing something very similar, right? At the very beginning, it's creating a plan for itself, and so you have this
Yeah,
main
it's just insane.
and then the subagent with its own plan, right? And everything we see here, right, this main agent can see. And again, it's not just doing it for one, it's doing it for, in this instance, 5.
Johnny, just think about how long it would take you to manually think about just the planning, the conception of these workflows, testing them out, trying what works, what doesn't, constantly hitting walls with errors coming up, with models failing, with not picking the right model, because also the orchestration agent is picking different models here, right? It could be a
Yep.
combination of an Opus and a Sonnet and a GPT and a you name it, right? So just the amount of time it would take you to come up with a plan to actually execute against this. This took you what, 5 minutes? Or you just put the prompt in, right? And it started working.
Yeah, I put the prompt in. So
It's
as long
insane.
as I would say maybe a minute to type all this out, think through and type this out. Yeah, I think, and again, if we take a step back and we go back to the beginning, what we were talking about with traditional workflows, right? So
Mhm.
what might this look like with a traditional workflow if I wanted to show a client, right? the value of executing stuff in parallel, I would have to actually build out, right? I would have to map out on a piece of paper or on a whiteboard I have in my office. I'd have to map everything out that I wanted to show. And then I would
Yeah.
have to actually build it. And then I'd have to test it and make sure
Yeah.
it worked, right? And troubleshoot all the errors manually. And then
Yeah.
after that, I have, right, a deterministic workflow that can run a couple things in parallel, right? But
Yeah.
it's limited, right? It can run maybe 10 things in parallel. If I wanted to run 20 things in parallel, I'm going to have to add to that workflow. And so there's all this manual work that we're saving now with these agents. And it's just getting more and more powerful and more capable. And this newest capability we have where the main agent can orchestrate and kind
Right.
of intelligently steer these sub agents is just kind of a game changer in terms of being able to make these agent swarms, right, as a lot of people call them, right, much more intelligent. And so it's instead of a team of people that can't see or talk to each other, it's now a cohesive team of people that have a really intelligent manager that can, micromanage them as much as is needed.
Right. And on the very top of this, of course, is you, right? Because you are, and this is what it comes down to, you are the one who's conceiving it,
Mhm.
who is then making the assessment if all of that ran the way that you intended it to run. But in the end, the agent is like your superpower to just multiply that 10x now. So it's way faster. It's way better. It's an incredible new step in the evolution of AI, something we haven't seen so far elsewhere. Johnny, I want to thank you again. This was fantastic. Great conversation with you. And if you guys are out there still using traditional workflows and you're wondering why your AI implementations feel rigid and slow, well, then maybe you're still building in this 1995 style of sequential processes, right? Now it's 2020, 2026. AI capabilities lead to entire new ways of working, which seems to be our common topic, Johnny, as we go through this. How does it change the way that we work? How does it change the way that processes are being addressed? How are problems solved? So all of this is currently totally being reinvented every single day, every single week. So we keep exploring the edges out there for you, and we will be back next week. And Johnny, thank you so much. Anyone who's interested, check the comments below. Let us know how it goes, what you like, what you didn't like, or if you have any questions. And we'll be back with you next week. Thank you so much.
Thanks, everyone.
Bye.